Hi, I'm Rich with Inside HPC, and we're here at the ASCII booth, and I'm here with Dr. Paul Woodward from the University of Minnesota, my old stomping grounds. Paul, it's been a long time, but I understand you've done some new work looking at how your codes might port over to the mic architecture. Can you tell me about that?
Well, we're seeing here a visualization of a run that we have done very recently in collaboration with Intel and also with Sandia National Lab and Los Alamos. And what we did is we took a simplified gas dynamics program, a full application, and we ported it over to Intel's mic architecture. And we've gone through the process of not just running on one mic accelerator card, but in this case running on 8 of them in multiple nodes. And so we've gone through the whole process of not just getting the code itself to run well on all of the cores, the 32 cores per CPU, but also to get all the messaging between these cores so that they could cooperatively do this calculation over a network. So there are quite a few things that we have to pay attention there. It's not enough to just get everything going very rapidly on one core. You've got to figure out how to coordinate all of those cores, 32 cores, 64 threads, and then you've got to also coordinate it with the other mic cards. And so there's quite a bit of tuning that we went through to make this run well. And it does run well. As you can see an example, this is meant to show you that it can do a real problem. This is a flow of a light fluid over a heavy fluid, and you can think of it just being like waves at the beach. It's the same in stability, but this is actually a fluid that is meant to represent a helium-carbon mixture inside a giant star.
Inside a star. Yeah.
And then the upper fluid is meant to represent a hydrogen-rich fluid that is located next to it at the top of what is called the helium shell flash convection zone. And so, well, it's not that different from waves at the beach. The only difference is the ratio of densities between the sort of water and sort of air is it's not quite as high as it is between water and air. And then the flow velocity is Mach 1/3, which is, I think, somewhere around the maximum air velocity that has ever been recorded on Earth. Yeah. So this would be a fairly violent day at the beach.
Okay.
You know, if you were on your surfboard, I think you could see it would be difficult to stay balanced. But basically, what we wanted to prove with this is that we could get our full application code ported over to this new and very exciting Intel architecture, get all of the many threads that we have to coordinate and all the different cards and get the whole thing going. And this is our first attempt at it. We're very pleased. Next we'll try more complicated code, and we'll try and scale this up, etc., etc. But we've been very pleased with the result.